The James Webb Telescope just did something truly incredible. On February 19th, 2026, for the first time ever, it captured the rotation of Uranus in full 3D for about 15 hours straight. Of course, the images are great and all, but the 3D time-lapse video here is something really astounding. What you are seeing is the very first ever vertical view of the ionosphere of Uranus, showing glowing auroras by its tilted magnetic field. That's basically the weirdest one in the solar system. So what exactly did Webb catch here? And why does it matter? We are going to take a look at everything Uranus has to offer, and you are also going to learn why this discovery is going to be a breakthrough in science and technology. Good day, everyone. I'm Rob Brandon, and with that said, let's get started. Uranus sits nearly 2.9 billion kilometers from the Sun. It's dim, far, and easy to ignore compared to Jupiter and Saturn. But Uranus also has one of the most extreme setups in the solar system. Because the planet is tilted on its side, about 98 degrees, so as it orbits the Sun, each pole can spend long stretches facing sunlight, then long stretches in darkness. That makes its seasons completely bizarre, and it makes its atmosphere hard to compare to anything else. And here's the real problem. We don't have modern close-up monitoring there. The only spacecraft that ever flew past Uranus was Voyager 2, and that was back in January 1986. I mean, way back. And it did a quick pass, about 81,500 kilometers above the highest upper layer of the clouds. Just one flyby, and then it was gone. So Uranus became the planet we talk about like we know it. But to be honest, we actually don't. Especially not the part above the clouds, where space weather hits first. And that's where the James Webb Telescope comes in. To understand why this new image is so important, we have to look at the technology behind it. The James Webb Space Telescope uses an instrument called the near-infrared spectrograph, or you can say NIRSpec for short. While our eyes see reflected sunlight, Webb sees heat and chemical signatures. By watching Uranus for a full 15-hour rotation, an international team led by researchers at Northumbria University did something truly impossible for ground-based telescopes. They mapped the planet's ionosphere, which is basically the upper layer of the atmosphere where the air meets space, stretching over 5,000 kilometers above the clouds. This image is not just an ordinary planet photo. It's actually a vertical map. And with this, scientists can now see exactly how the temperature changes as you move higher into the sky. Awesome, isn't it? But here's where things get even more interesting, as there was another result hidden in the data that confirms a long-running mystery. You see, Uranus's upper atmosphere is cooling. Scientists measured an average temperature of about 426 kelvins. That's around 150 degrees Celsius. Now, it might sound hot, but in planetary science, what matters is comparison. Previous measurements showed higher temperatures. This new value, however, is lower. And when I told you about the long-running mystery earlier, this is it. The trend isn't new. The cooling appears to have been happening since the early 1990s. For decades, no one knows exactly why. Uranus receives very little energy from the Sun, and unlike Jupiter or Saturn, it doesn't release much internal heat. It's one of the coldest planets in the solar system, and Webb just confirmed that the upper atmosphere is continuing that trend. Still losing energy, still changing, and now we are finally seeing the vertical structure of how that heat is actually escaping the planet. If you think Earth's magnetic field is simple, wait until you see Uranus. On Earth, our magnetic poles are roughly near our north and south poles, but on Uranus, it's somewhat broken. Its magnetic field is tilted at a 60-degree angle from its axis. Not only that, but the center of the magnetic field doesn't even sit in the center of the planet. Its offset creates a lopsided magnetosphere that wobbles as the planet spins. Because of this chaos, the auroras on Uranus, what we would call the northern lights, don't really stay at the poles. They sweep across the entire planet in complex glowing patterns. Webb's new 3D data captured two massive bright auroral bands. But between those bands, scientists found something really unexpected: a depletion zone. It's a massive gap where the particles and light simply disappear. This gap is a direct map of the planet's magnetic transitions. It shows us exactly where the magnetic field lines are snapping or shifting. For the first time, we can see the invisible forces that protect or warp the planet's atmosphere in real time. Quick pause. If you like space documentaries that provide you with real details and genuine information, then subscribe. You might be wondering, why spend billions of dollars and years of research on a planet like Uranus? The answer lies far beyond our own solar system. When we look at planets orbiting other stars, exoplanets, the most common type of planet we find, isn't a rocky world like Earth or a gas giant like Jupiter. It's the ice giant. Most of the planets in the galaxy are likely very similar to Uranus and Neptune. By understanding the energy balance of Uranus, how it cools, how its auroras work, and how its lopsided magnetic field behaves, we are creating a blueprint for the rest of the universe. If we can't understand the ice giant in our own backyard, we have no hope of understanding thousands of others that are light years away. As lead researcher Paolo Taranti said, this is a crucial step toward characterizing giant planets beyond our solar system. We are learning how planets manage their energy, and that knowledge is the key to find potentially habitable moons or unique atmospheric conditions across the Milky Way. While the 3D mapping is the latest headline, it's not the only thing James Webb has found recently. In late 2025, the James Webb Telescope spotted something that every other mission had missed: a brand new moon. Temporarily named S/2025 U1, this tiny moon is only about 10 kilometers wide. To give you an idea of how small that is, you could drive across the entire moon in about 10 minutes. It's so small and so faint that even Voyager 2 couldn't see it when it was right next to the planet. This discovery brings the total number of known moons around Uranus to 29, but it's not just about the number. S/2025 U1 orbits right between two other moons, Ophelia and Bianca. Its presence suggests that the ring system of Uranus is far more dynamic than we thought. These small moons act like shepherds, using their gravity to keep the rings in place. Interesting, isn't it? Finding this moon in 2025 was the proof of concept for James Webb's power. It showed that the telescope's sensitivity is so high it can find a tiny rock millions of miles away against the overwhelming glare of a giant planet. The James Webb Space Telescope has given us the image we've been waiting for, but it's more than just a picture. It's a 3D data set that will keep scientists busy for decades. We now know that Uranus is a world in transition, a cooling giant planet with a magnetic field that acts like nothing else we've ever seen. From the discovery of new moons to the mapping of invisible auroras, Uranus is finally stepping out of the shadows. It's no longer just a blue ball, but a complex, energetic, and mysterious world that holds the secrets to the most common type of planet in the galaxy. Thank you for watching this scientific journey. If you want to stay updated on the latest genuine discoveries and the mysteries of our universe, make sure to subscribe and hit the notification bell. so that you get notified every time a new video goes live. But before you watch our next video, what do you think is the strangest part of Uranus? The 3D auroras, or the fact that it's cooling down? Let me know in the comments below.